Alright, it's live now. Alright, welcome back to day 3 of Solf or Go Home. 30 minutes solve or go home. Alright, let's see today's question. What is today's question? Global and local inversions. That does not sound fun. Alright, let's see. We have some permutation of A, 0, 1, dot, dot, dot. Oh, wait, I didn't start the timer. Oops. Okay, there we go. Where n is the length of A. Okay. So permutation of A with a increasing sequence, I guess, of ints is number of global inversions is number of, oh my god, what is this crap? Who designed this question? I don't want to do this.
You can just walk through an example. That's the easiest way to understand.
Yeah, okay. So input A equals 1, 0, 2. That's true because there's one global inversion, one local inversion. That doesn't do anything because I still don't know what a global and local is. Okay.
So look at the definition, right? In line 2, number of global inversions is places where your current index, your current element is greater than where it would be normally sorted, right?
Oh, if it was sorted.
All right. So in this case, in example 1, right?
Yeah.
Index 0
is smaller
is bigger than index 1, even though but so there's one global inversion here, right?
Yeah, because
normally
it's in the wrong place.
Smaller.
It's in the wrong place. Is that what you're saying?
Correct.
Okay.
Right.
And then local inversion is when it's. Oh wait. Both basically inversions are just if they're in the wrong place. It's global if it's bigger and it's local if it's smaller.
It's local if it's between this one and the next one, right? I and I plus 1.
If it's between, okay, number of local inversions is the number of I where 0 is less than or equal to I less than n, and A of I is greater than I plus 1.
Right.
So in example 1, the local inversion is what? Is it also the 0?
All right. So at A of 0 is 1, and A of 1 is 0. So if 1 is bigger than 0, this is wrong. This is in the wrong place.
Well, yeah, but why is that a local inversion also?
Because you're only comparing something to the next thing. You're not comparing something to something else.
Oh, so global means like literally global.
Yeah, I think more useful example is number 2, right?
Yeah.
But in number 2, if you look,
so there's 2 global inversions because 2 is in the wrong place and 0 is in the wrong place.
Well, not quite. It's more that position 0, sorry, index 0 is 1.
Yeah. Okay.
And index 2 is 0, right? So 1 is bigger than 0.
Yeah.
Right. That's the first global inversion. The second global inversion is that index 1 is 2, and index 2 is 0. So 2 is bigger than 0.
Okay.
Right. So it's basically if there's any number earlier that is bigger than any number later, that is a global inversion.
Okay, sure.
And if you compare, the number to the numbers next to it. Right?
Oh, I see. So like one compared to 2 is fine because that's increasing by 1. So that's not a local inversion. Right. But 2 going to 0 is a local because 2 is way bigger than 0.
Correct.
What if it was 1, 2, 3, 0? That would be 3 global and 1 local?
That's right.
Okay. All right. So basic algorithm here. Basic algorithm is you kind of want like just loop through it and then like compare each element to the next one like a sliding window kind of thing, and then you can just grab all the locals that way, and then global you can check by how would I check global if it's greater than If it's great, if anything, okay. So maybe, how do I check global? Local seems way easier. Okay, that's fine. Global is if there is. Okay. Global.
So the whole problem is to find, I guess, when local and global are equal, right?
Yeah. So are you saying that there's a shortcut you don't even have to calculate? You still have to calculate them, right?
No. So I guess the converse to this problem is in what scenarios will there be? Actually, let's take it one step back, right? Can global inversions be less than local inversions?
Can global be less than local? Say if possible global. I don't think that's possible because then
Okay.
if you have locals, that means there's definitely stuff out of place. Then you have to have a global. For every local, there has to be at least one global.
Exactly. So we just want to find the scenario where uh, for every local inversion, there's no additional global inversions. Right?
Yeah. So basically, what the the, the algorithm just is basically you're just looking for if global is greater than local. That's it. Because then everything
Correct.
else cannot
So,
happen.
and it is also sufficient to find to construct, I guess, a permutation such that the you only have local inversions, right? Because if you only have local inversions, then you will never run into the scenario where you have more global than local.
Okay, but wait, when you say permutations, you're not allowed to make permutations, right? Isn't this like this set input? You can't change the indexing of it.
Right. But you can parse it and say like, is this all local or is it not?
Oh
And if
yeah,
the
I
answer
mean
is
just loop through it
it,
and just check to see if there's yeah. So yeah, I mean building local count is not hard. That's like just sliding, right?
no,
But
it's
then
not. It's not about counting local, but it's more that uh, for a given permutation, if you know you have local count, but you want to make it such that the global permut inversions also sorry, there are no additional inversions. Right?
yeah, but yeah, but in order to do that, don't you have to have the logic in place to handle the global count, right? Like how that's
No. So there's two ways to do this, right? What you're suggesting is something that is kind of brute force. You're saying let's count global, let's count local, and see if they match.
oh okay yeah.
Uh,
Mm-hmm.
right? But what I'm saying is that you don't have to do that because if you can check that the permutation belongs to or is of a certain type, of a certain pattern, then you will know that it only has local inversions. In which case, the global will equal to local.
Oh, you're saying if I can rearrange the input into a way that it's only locals, then you're saying that local would equal global in that context.
Well, I'm just asking you to solve a smaller problem, which is like, in what scenario is local equal to global?
In what scenario is local equal to global? Okay, so I guess that would be well. The example one is local equal to global, where it's just
Right.
one element's out of place. Well, I guess two elements are out of place, but like yeah, when there's only
Right.
yeah when it's two
Correct.
when it's two elements out of place yeah. Wait,
Uh,
why is example one only one local? All right, so when you go from one to zero,
mhm. Say
that's
local.
that's a local, right? But when you
Mhm.
go zero to two, isn't that also a local?
Oh, because zero smaller than two.
Oh, so as long as it's smaller, it's fine. I thought it had to be like increasing by one. Okay.
Correct. So what if we had array for 0, 1, 2, 3, right?
Yeah.
So can you construct several where there's oh,
Where there's what?
only local inversions?
Only local. So why is it C plus plus? So if it was you're saying 1, 2, 3, right? And 0? Is that what you're saying?
All right. So let's start with this, right? How many local are there?
0.
Okay. How many global are there?
0.
So is local equal to global?
Yeah,
correct?
that's true. Yeah.
Okay. So now let's try to have one thing out of place.
Okay, so if I do 1, 0, this is one local, one global.
Right.
Yeah.
It can also be, you can make another one where you don't swap the first two, right? You can swap the middle two.
Yeah. Sure. So if I go back to this to 1, so that's one local and one. That's one local, one global. I think. Yeah.
That's correct. And you can also do this with any other position, right?
Yeah.
Like you want to swap the last two instead of the middle
so
two.
if I do 3 and 2, yeah, that's also one local, one global.
Correct. Is it possible to have two local, two global?
I think. Wait, let me see. So if I did 3 here and 1 here, these two would be global, but then this is only one local. I think. Is this one local?
No, this is. Oh yeah, you're right. That's one local.
So this is one local and two
That's
global.
not right.
Yeah. So this
So that's
one.
not right.
This. Wait. What do you mean it's not right? This. This is not what you're looking for. But.
Correct.
Okay. Yeah, I see what you mean. Okay.
So the strategy here is to flip the statement, right? Saying like, let's find scenarios where you can get them to be equal.
Okay. So this one, there's two globals, and there's two locals, I believe.
Not quite.
Wait, why is that?
There's three globals, right? Because 3 is bigger than 2, 3 is bigger than 1, and 2 is bigger than 1.
Oh yeah, you're right. Okay. I did 3.
So I think you should probably have the 0 and 1 cases written out as well, just so you can see the pattern.
Wait, what do you mean write them out? What do you mean?
The ones where we have verified that there's 0 global, 0 local, and then 1 global, 1 local.
Oh, okay. So 1, 2, 3. That's zeros. 0 local, 0 global.
Yeah, just put another comment at the bottom.
And then it'll be 0, 2, 1, 3. Local, global. And then like any other iteration of just swapping one number, it's also one local, one global.
All right. Just for identifying a pattern, I think it's useful to see.
Oh, okay. So you just list them all out?
Yeah, for now. It's a small example.
Sure. All right. So it's 1, 0. I already have this one.
Okay.
Is that all the permutations?
So let's say we want 2 local, 2 global, right?
Yeah.
I'm going to give you an example, which is 1, 0, 3, 2.
1, 0, 3, 2. Okay.
Okay. So can you verify that the local and global match?
Local and global. Okay, so 1 is greater than 0, so that's 1 global and 1 local. 0 is less than 3, that's fine. 3 is greater than 2, so yeah, that's 2 local, 2 global.
Correct. Okay.
Okay.
So I guess my question for you is, among the things here, where is position 0? Or for these valid cases, where can 0 be?
0 can only be in the first 2 slots.
Right.
First 2 indexes.
Right. And where's 1?
1 can be in the first 3 indexes.
And where's 2?
2 can be in, the last 3 indexes.
And where's 3?
3 can only be in the last 2 indexes.
Right. So I guess more generally.
Yeah. So the biggest number can only be in the last 2 indexes. The smallest number can only be in the first 2 indexes. And then the middle numbers can span 3 from the left and 3 from the right.
Well, okay. So if you look at first in line 4 with the 0 and 0, right? This is the purely sorted array.
Yeah.
Okay. So you're saying that 0 can be in its original position or 1 after, right?
Mm-hmm.
And then for 1, it can be in its original position, 1 after, and 1 before.
Yes. Yep. And 2 is the same way. Can be in front or behind. And 3 can only be in front or its original position.
Because after, it's going to be out of range. So,
okay, yeah. So, yeah, that's just constrained by the out of range index.
So now, would you say that getting the correct permutation just means that for each index,
the number can only be in the left or right position to it. You can only swap with left or right.
Or itself.
Yeah. So it has 3 states. It can be left of itself, right of itself, or in its current position, unless it's out of range. Then it cannot be out of range.
Correct. So that should just, give you the algorithm that you want, right?
Okay, yeah, but so this would basically these permutations are saying that the local is equal to global, and in that case you return true. So basically the algorithm is checking if you can make this permutation, then you're true. If you can't make this permutation, then it's just false. Is that what you're trying to get at right here?
What I'm trying to get at is that for each of these values in the array, if it holds that they're in the correct position or plus or minus 1, then you know that you have a valid permutation.
Yeah. So is your algorithm? Are you like scanning through it to try to see if it can build this permutation, this correct? Basically, you have to loop through the array and check to see if each element, if swapped, can build a valid.
You don't have to know the swaps. You have to know that if you're looking for position for the number 0, right, and you don't find it in position 1 or 2,
then it's
or position 0 or 1, and then you immediately fail.
Yeah, that's fine. Okay, so you're looping through the array, you're checking. You start with index 0, and then if 0 is not in index 0 or 1, that's immediate fail. If it is, you keep going and you check 1, and you check 2, and you check 3. Is that your algorithm?
All right. So if there's any scenario where your dude is way too far away and it cannot be swapped in 1, then it's not ideal, right? It doesn't match this condition.
Mm-hmm.
But if you go through all of it and they all match,
then you're good.
You know that you're good, right?
Okay, I see. Okay, so you kind of want like a sliding window kind of thing, where you just check the element. You check the first 2 boxes. You loop through basically on the length of the array, because it has to be unique numbers, right, between 0 to n minus 1, and then you have a counter so you start with 0. You check to see if 0 is in 0th position or 1 position. If that's good, then you move on. If that's not good, you immediately return false, and then you check the next number. If that's in its index, or 1 in front or 1 in back, if that's good. Then you keep going. All right. Okay, that seems doable. All right. So let's see. So we'll do len A should be the numbers you're looking for. So maybe like, well, I don't know why I'm saying var. I guess it would be for I in len a. It would be range len. Although that would exit it too fast. I think you need a while in front of it.
No, not necessary. You know what the previous index has to be. You know what the next index has to be.
Oh, right.
You know
right.
what the current index has to be.
That is true. Okay. So for I in range len. Okay, so if wait, but we can't do I. We have to do index, right? Unless we have another var to handle.
I is index.
Is it? Oh, in range is it index?
So this if you do len, if you do for I in range len, like
then
10,
it would be
get
index,
0 through 9, right?
Yeah, okay. All right. So then if okay, yeah. So I just have to border check because then it's the same logic beside either way. Okay, so I just make sure I'm not out of range. If I minus 1 greater than 0 and I plus 1, I guess we don't do it and, because then it can't be greater than 0 and less than, wait, no, I think it is I plus 1 less than len a. Then you check, you do a I, if
what you could do here is, because you know all the neighbors are either minus 1, which is less, plus 1, which is more, or itself, which is same, right? You can check at the time that you're looping through the neighbors whether it's in range.
Wait, what do you mean?
So you know that each neighbor is defined, right? You're always checking before, current, and after.
Okay, yeah.
So then you can just check afterwards at the time that you're checking each neighbor whether it's in range. So you should define something like neighbors equals I minus 1, I, and I plus 1, or something like that.
Oh yeah, you mean just define the vars and then so you have them, you'll have access to them. Is that what you're saying?
No, I'm saying that you're going through each index, but then for each index you have three neighbors to check.
Yeah. Oh, you're saying, okay, I see. And then you're just constantly updating them as you go, so you don't have to grab them, keep grabbing them. Is that what you're saying? Like,
not quite. So at position 0, you have to check what? Minus 1, 0, and 1, right?
Yeah.
But you only want to do that if it's in range. So you should be like for neighbor and neighbors. Don't even access it. Just get the indices.
What are you doing with the indices then?
You loop through these 3 things.
Okay. So you're just grabbing the indexes and then you
If
loop.
the index is in bounds, then you check.
Okay. So neighbor goes I minus 1. There goes I neighbor. And then and then if left neighbor is in bounds, right? If left neighbor is greater than 0.
This is not very. You could just say neighbors equals in an array and then these 3 things.
Oh, okay, I see. Okay.
Right. Now you can check for it. Sure.
Well, I probably shouldn't use the same bar.
Yeah, you should not use the same bar.
If j is greater than is less than greater than 0 and j less than greater than 0 or less than when a, right? If it's greater,
Why or?
I'm just checking the logic here. I think it's and, but wait. If it's greater than 0 or, yeah, or it doesn't work.
And technically you want 0 to be returnable as well.
Oh, yeah, you mean
What if you're in checking position 0?
Yeah, no, this would
not work.
no, this is if it's greater than 0 or, oh yeah, because it's greater than or equal to 0. Okay, yeah, that's fine. And then so for j neighbors, if this happens, then you check a of I, or a of j, I guess.
Okay.
So if a of j equals I, or a of I,
Okay.
then you're good.
Wait. What?
No, because then
That will never be the case unless it's already all sorted.
no. So you're checking to see if neither of them, if none of these are the element. So if none of these are I,
Where are you
then you're
checking the
screwed.
element?
What?
Where are you checking the element?
You know, I'm thinking right now. So yeah, this I'm trying to. So you do I think you just loop through the full thing, and then if it doesn't equal, if it doesn't equal, you exit too early. You can't do that.
Right. It's if any of them equal.
Yeah, I know. That's why I tried to do the equals. But then yeah,
Equals is fine.
It's not j equals to I. Wait, no, it is j, isn't it?
This part is correct so far.
No, I think that's correct. If that is, then you return true.
No, this will never be the case unless it's all sorted.
No, because you're looping through all of it. So it will be the case, right? Wouldn't it?
But you're taking A here.
What do you mean?
We know it's a permutation. A of j will never equal A of I unless j equals I.
No. Why is that?
Look at all your examples. Is A of I ever equal to A of j? It's a permutation.
Oh, no, it's not supposed to equal A of I. It's supposed to equal I.
That's right. That's what I was saying.
Oh, yeah. I was confused. Okay, and then after you finish the whole loop, then it's return false otherwise.
No.
Yeah.
Not quite. So why are we returning true so early?
This
means that
this should be a helper function. This shouldn't be inside here. Oh, definitely.
I don't know if you need a helper function. I think you need a flag that says you find it or not.
Yeah, the helper will return. It returns true if it found it. Otherwise, it returns false, and then that should handle all the cases.
Oh yeah, sure. You can do that. Or you could just use a flag that says I found it or not.
I mean, sure, you could also do that too. I don't know. This is how I typically dev for JavaScript. I use a helper function.
That's fine.
Alright, whatever. Found equals false. Alright, then if not found, return false. Else you continue. Right? Oh, I'm going home today. Fail. Epic fail. Alright. So yeah, so each eye you build the new neighbors, and then you set a new found, and you loop through it. If you found it, it's true, then you're good. If you didn't find it, then you return false and you exit the whole list. So you're good here. Otherwise you keep going and you go to the next one. And then you just return false overall, I think. Oh wait, no, you have to return if it's good, you have to return true. So when do we check to see if it's all good? So if it's, I mean, I guess no, it's return true overall because the falses will handle itself.
Right.
Yeah, so I think, alright, so let's run through it with the 0, 1, 2, 3. So length A is 4 here for I in range of 4. Range length 4. So I think it starts with 0. Does it start with 0, right? For sure. I think it does. Alright, so it goes 0. I minus 1 is negative 1, 0, 1. Found is false for j and neighbors if j is greater than or equal to 0. So negative 1 is not, so it's not going to do this. And then it's going to go to the next one, which is 0. It is greater than or equal to 0. And it's also less than 4. So that's fine. So if a of j, currently j is 1. A of j,
no, currently j is 0.
No, you're right. J is 0. Yeah, okay, yeah, my bad. Yeah, j is 0. A of 0 is 0. And 0 is equal to 0. So you found it. So that's good. And then you just, well, it doesn't exit. I guess I can exit and just do a.
Yeah, if you want to optimize it a little bit, sure.
What is the Python?
A break.
Oh, it's a break. Oh, it's the same thing. Okay. All right, yeah. So it breaks, and then if not found, return false. But it's found, so we ignore this, and then we go to the next one. Now it's 1. Yeah. So index is now 1 also. So I is 1. So this one is 0, 1, and 2. Found is false, and then you check the neighbors 0, 1, and 2. 0 is greater than or equal to 0, and it's also less than 4. That's fine. And then a of 0 is not equal, so loop again, and then it'll be a of 1. That is equal, so you found it, so it's good. And then you skip this, okay, and then you go to the next one, which is 2. 2 would be here, 1, 2, and 3. Back to false, and then yeah, so 2, what is it? It's 1, 2, and 3, yeah. So you check 1. 1 is not equal. Checks the next one. 2 is equal. So I found it. Alright. Yeah, so this one works. This one. Alright, let's try this one. Alright, 1. So it starts with index 0. So this is 0. So you go negative 1, 0, 1. And then you come in here. And then check j is 0. So 0, wait, no, it's negative 1. So it skips this one. Then j is 1. And then do a j is 0, and then it comes in here. and then you check if a of 0, which is 1, is equal to 0. And it's not. So it checks, it goes to the next one, which is this position. I plus 1 is 1, yeah. So a of 1 is 0, and 0 equals 0. So you're good. And now,
Okay.
yeah, I think this works. I just wait. Should we test one that is not local?
Yeah, go for it.
So the non-local one was what? What was it? It was 0. It was 3, 2, 1. So this one has what? 3 globals and 2 locals. Is that correct?
Well, three global, right? No, 4 global,
It's 4?
and yeah, 3 is bigger than everything.
Oh. Wait, but if it's bigger than everything, isn't that just 3? Why is it 4?
Yeah, and 2 is bigger than 1.
Oh, okay, that's why. Okay, I forgot that. Okay, so that's 4 global. And then local is 1. Wait, no. Is it 1 or 2?
2.
It's 2, right? Okay. Oh, I don't know why I switched it. Okay, so if you plop in 3 here, well, index 0 is same thing. -1, 0, 1. 0, -1 obviously doesn't go through here, so just check 0. A of 0 is 3. 3 is not equal to 0, so that's not good. And then you check this position. This position, we get I plus 1 is 1. So 0 equals 0, so that's good. So you do continue. And then you check this position, which is index 1. So you got 0, 1, and 2. And then a of 0 is 0. And then does that equal 1? No. So then you check, actually no, you check here first. I think, yeah. The 3 doesn't equal 1. This doesn't equal 1, and this also doesn't equal 1, so it fails. So it will found is false, and it's going to return false. So that's good. Alright, I guess we can test it out then. Alright, let's put custom test case. Let's try this one. Oh, that's good. Try this one. Oh, that's good too. Alright, try one more. And that's also good. Alright, so submit. Oh, nice. It good.
Okay, so my question here is, I guess, I don't know if I pushed you too hard towards this particular algorithm, because you were going to go with the brute force method, right?
Yeah,
Which
you
can imagine.
I did not. Yeah, the brute force part is definitely bad. So
brute force is going to have the order of n squared, right? Because you have to check
yes.
every single thing against every other thing.
Yeah.
So I guess, you know, this ideal permutation is actually, like, if you look at kind of pairwise elements, you can see that sending it through like a bubble sort pass will solve it. Right? Like basically anything that works here can be sorted by bubble sort in a single pass.
Okay.
Right? Like it's like 0 versus 1. Okay, you swap or don't swap, and then it's 1 versus 2. Swap or don't swap.
Yeah, bubble swap is n squared though, right?
Yeah, but that's because of n passes. But you're just doing one.
Yeah.
Okay. Well, I mean, that's kind of it for today, right? So,
Yeah.
uh, maybe the lesson here is oh, um, write out some examples, see the pattern, and then go from there.
Mm-hmm.
The other thing is, you know, if you have the same pattern over and over with regards to like what your next neighbors are, then you should just define them and then check at the time that you process them whether they should be processed. And then I guess your helper function thing, probably is also a good idea. A flag is equivalent in this case.
Yeah, I mean it's the same thing really. It's just you abstract the logic out to its own helper, so
Right.
it doesn't look convoluted here. Cause in
Right. And then I guess another sticking point was you had the a of j equals a of I.
yeah,
That part you were somehow stuck on for a long time. So
yeah.
yeah, that's it.
All right, cool. Thanks. Bye.
Bye.